Poisson's ratio, which is denoted as mu, and the Poisson's ratio, this is the ratio of the lateral strain and the longitudinal strain. Now consider this rectangular body which is subjected to some axial load here. Let's take the load as P1, which is tensile in nature here, and as a result we'll see that there will be some stress also. Let's take the stress will be sigma 1. The strain, that is change in dimensions here, this is how the body will deform on the application of this load. And this deformation, you can see that, let me take this as the x coordinate, the x-axis, and this is the y-axis. Now you see that the x-axis is actually the line of action of the force itself. That is, this is the longitudinal direction. And along the longitudinal direction, we saw that the length is increasing here. The length is increasing. So we saw elongation. Along the longitudinal direction. And along the lateral direction, you see the length has decreased. Now the length is this, but initially the length was this. So along the lateral direction, we saw that there is reduction in length. So based on this, I can take the lateral strain will be negative and the longitudinal strain will be positive. Now, if I have a compressive load, instead of tensile, if I have a compressive load, which will be acting inwards, in that case, you will see that this is how the body will deform. That is, in that case, the lateral strain will be positive, since along the lateral direction we have the length has increased here, so that will be positive, and the longitudinal strain will be negative, since in that direction there is reduction in length. So in Poisson's ratio, you see that the lateral strain and the longitudinal strain will have opposite signs. So generally I can write this as Poisson's ratio will be equal to minus lateral strain by longitudinal strain. Now, if I have to write the Poisson's ratio in terms of its dimensions, then I can write, first let me take the dimensions here. This is the length and this is the breadth. And we know that strain is change in dimension by the original dimension. So I can write minus the lateral strain will be change in the lateral dimension. The lateral dimension, that is breadth, change will be del B by the original dimension, that is B, divided by the longitudinal strain, that is the change in the longitudinal dimension, that is del L, by the original longitudinal dimension, that is L. So this is writing the Poisson's ratio in terms of the dimensions. Now this equation, I can also write this as lateral strain will be equal to minus mu into longitudinal strain. So this is writing the lateral strain in terms of the longitudinal strain. And the longitudinal strain here, you see that I got some stress here. On the application of load P1, I got stress as sigma 1. Now, the strain, we know that the strain can be written as strain will be equal to, I'll write here, strain will be equal to stress by the Young's modulus. We know this. So this I'll be applying here. Now you see that the stress we got here is along the longitudinal direction. This direction is the longitudinal direction. So I can write the longitudinal strain will be equal to the stress along that direction is sigma 1. Sigma 1 we got. So sigma 1 by E. So this will give the longitudinal strain. Remember, this is the longitudinal strain. And now this will be getting minus mu here. This is the lateral strain. So lateral strain is equal to minus mu into sigma 1 by E. And the longitudinal strain is this. That is sigma 1 by E is the longitudinal strain. Now what we see here in this equation, you see we get just sigma 1 here, which means that only we are getting one stress along this direction, sigma 1. Along the longitudinal direction alone we are getting this stress, which means that only one load is applied here. So this is called as uniaxial loading, load acting along any one direction alone. Also we have biaxial loading. In case of biaxial loading, we'll see that there will be two forces, one along the longitudinal direction, P1 is that, and also the other force will be acting perpendicular to in the perpendicular direction. So we'll have one more force as P2, and as a result of this we'll get sigma 2 as well. So for biaxial loading we'll get two stresses, sigma 1 and sigma 2. So we'll see the longitudinal strain and the lateral strain for that in terms of sigma 1 and sigma